Hello and welcome to the channel. So we have a Fender Vibrolux here. Now this Vibrolux has been on the channel before, blowing the mains fuse, and we had a look at it, we recapped it, it went back to the customer and we did suspect the power transformer, and it did carry on blowing fuses. So after checking everything, the rectifier tube, everything else, we did eventually come to the conclusion it was the transformer. So we've had the transformer rewound. Now I'm not going to cover fitting this transformer massively. What I want to focus on this amp is problem that these boards have. Now if you look at this board, it doesn't look in particularly great condition. We've got this gigantic hump in the, not quite in the middle, and that's obviously from moisture, damp at some time. Now these boards were coated in wax, and the problem with this amp, and I tested this previously when we looked at it, there's grid voltage, there's plate voltage leaking onto the grids of the preamp tubes. And of course your first thought is, oh, that'll be the coupling caps. But then when you start to put the meter on various parts of the board, you're picking up voltage leaking onto this board. It's become conductive. And when you turn the pots on this amp, they're scratchy because they've got DC on the pots. So if we look at this pot here, you can see we've got this swishing sound going on, scratchiness, and that's because there's DC leaking onto this pot. And if we just go in here, you can see we've got 1/4 of a volt there. We had as much as 1/2 volt yesterday, so maybe this board is drying out a little bit. But now if I put the meter on the board, you can see there's 1/2 volt there on the board. So put the meter here, 1.3 volts leaking onto the board, 1.9 volts, 1.8, well, that's fluctuating, 1.3 volts leaking on the board, 1.1, we go up here, 0.5, 2 volts, 0.7, 1.4, even on the edge of the board there, 3 volts, 2 volts, whatever. So you can see this board all over is conductive. Now someone could argue and say, well, if you can put up with the scratchiness, that's not a problem. But the problem is that voltage leaking onto the grids will shorten the life of the preamp tubes because it's making them run hotter. We end up with positive volts on the grids. And you could also argue that it's changing the characteristics of this amp, because if you're altering the bias of these tubes, then one could argue that we're altering the sound of the amp. So what can we do about that? Well, 1 or 2 people in the past have cleaned these boards, cleaned off all the wax, and that's what I'm going to do, and that's really what I want to focus on in this video, because we've done enough videos fitting power transformers and things like that, and I wanted to just focus on this board. Now we're not going to be able to get the hump out of it without taking screws, move it, and obviously I'm not doing that. It's a vintage amp, I don't want to be drilling holes in it. I've never cleaned one of these boards before, so this is a first for me. I've read where people have, we mentioned it in the last video, and people left some really useful information. Some people saying they'd cleaned these boards and it had been successful. Some said it had been successful, but 6 months later it was back to scratchy pots again. But I'm going to clean this board. And I've offered to do this for the customer because I wanted to do a video on this, and just for the channel, for everybody that's watching. Some of you will have already done it before, and if you have, that's fine. You may have used different things to clean it with. I'm going to use alcohol to clean this, get all the wax off. I don't know how long it's going to take me. I know Lyle Caldwell from Sonic Audio has done some of these, and he was saying it took him hours. So I don't know how long it's going to take me. Now, to do this right, in my opinion, to do this right, you've got to lift the components. I can't see the point in cleaning round these components and then leaving the wax. So if we look, for instance, at these two resistors here, where they're going into the same eyelet, there's little point in cleaning round them and then leaving the wax underneath the resistors, because obviously this board was sprayed before the resistors and capacitors were put in. Otherwise we'd have wax all over the components, because we're just going to have leak points, under the resistors and things. So I'm going to lift all these resistors. Now, some people again are going to be arguing that, well, that's a vintage amp and you're doing loads of soldering on it and blah blah. But I'm sorry, I'm at this opinion. If this amp isn't running properly, it's no good. It needs to run right, and whatever we need to do to make it run right, in my opinion, we're going to have to do that. Some people will disagree. Don't berate me in the comments. I don't want this to turn into a debate, and I certainly don't want it to turn into a trolling match like you get on Facebook and all the rest of it. And we don't allow that on the channel anyway. Those comments will just be deleted, because that's not what my channel's about. Which is why I don't really put much on Facebook, because I can't stand the trolls. And I see it all the time where people, have put something up on there, or they've asked a question simply because they don't have that knowledge, and all you get is sarky remarks from all these texts on there, and just nasty comments. And I know other channel members have mentioned that. Shango 066, I watch his channel quite a bit, and he was talking about a guy that put a television up on there, his own television, which were worth $50, and of course the guy had switched the television on, and Shango was saying it was just all out war. They just absolutely rinsed the guy over a television that he owns. It's his television. So it's almost like, well, it's your television, but we own it, because it's a vintage television. But anyway, the top and bottom of that was Shango reached out to him, or contacted him, and offered to help and sorted the TV out for him, because that's the kind of guy he is, I guess. I've never met him, but he certainly appears to be on the videos. So I don't want my channel turning into the troll war. We keep the comments constructive. We keep we don't have the bad language, and as I've said, nobody swears more than me. I don't want it in the comments. I don't want nasty comments leaving. I just want, if people are criticising something, keep it constructive. But I set this channel up to help people who want to, work on these amps, who have got some knowledge and want to gain more knowledge, and people who just enjoy this and want to be a part of it. That's what the channel's about. There's no clickbait on my channel. When you look at the images on the videos, no clickbait. I don't do any of that. If you want to watch the videos, then by all means watch them. Nobody's being enticed onto the channel. I've now set up a community on YouTube, and I've already been putting a few posts up there. And if anybody wants to post on there, just say you've built an amp and you want to put the pictures up of the amp you've built and whatever, then by all means you can add those on there. Please feel free to, because then everybody can have a look at that and share knowledge, and people can give you advice. But again, I need to keep that right. I don't want it trolling and stuff. So any of you regular watchers that are building, I know 1 or 2 people have spoke to me, you know, at the moment I'm building this amp and things. Now, if you want to leave some pictures up on there, then that'll be great, and we can build a community. Anyway, enough of me waffling. So we're going to get this transformer fitted, and you can see we've got all the wires here swaging, waiting to be so we're going to get that fitted. Right, we've got the transformer wired up, and what I've done is put a low wattage bulb in the current limiter. We've not got any form of rectification yet, so I've tested for AC volts on the high tension. I've tested for filament voltage at the, I've tested for bias voltage at the tubes on pin 5. We've got bias voltage. Checked for filament voltage on the rectifier tube socket. We've got voltage there, and I've checked the 6.3 feed, and we've got voltage there. No shorts, drawing 40 milliamps with a 15 watt bulb in there, so not drawing hardly any current, and that's working absolutely fine. Now I'm still going to bring this amp up slow, and I'm going to use a solid state rectifier, but I'm going to keep it on the current limiter, so we should be fine with that. So we're going to put the tubes in, the output tubes, and I'm going to put this rectifier in there, start on some low wattage bulbs, and we'll bring it up and see if we've got life. Now I've changed the tube socket as well for the rectifier tube. And it's something I like to do when on these type of amps, when it's had a new transformer and there's been a transformer fault, because for what it costs, and the tube socket, it worked okay, there was no problems with it, but I did notice there was a little bit chipped out of it near one of the pins, and I thought, well, I'll change it anyway, because if we've got a new tube socket in, then we know we've got no problem. So new belt and socket in there. Right, I can see we've got the meter there, and if I flick the standby switch on, you can see we've got volts to the plates. We're drawing 40 milliamps off the wall, so it's no big deal. So I think we can get the tubes in and give this a blast. Right, we've got a bit of sound. We've still got it pinned down on the bulbs. We've got a couple of 6L6 Coke bottle test tubes in there, because we're not running this voltage up high. They're in fact, they're the ones that we used in the Masco, that were no good, the ones with all the elements shaking out, but they're good enough for test purposes. So yeah, 260 volts, and we've got a bit of sound. We've got it pinned down with 55 watts of current limiting. We've got 137 volts going in it, so let's go up to 100 watts on the bulbs and swage. Bulbs are dim, you can hear it coming up now, not very loud mind you. It's a bit weird. Oh, we've got a problem with this socket, looks like it. Oh, we're just gradually coming up now. Yep, there we go. So we're drawing up 230 milliamps now off the wall, 157 volts. I'm not going to push those Coke bottles any further than that. We've only got 157 volts going in. Let's try the other channel. Yep. So that's all looking good. Just check the negative volts. On there. Negative 35 already. So that's good. Yep, that's all looking good. That's good. And the reason we don't want to push those Coke bottles, they only have a dissipation of 19 watts. So we're not going to run those up to full power. No way. That would be silly. But just up to 150 volts on the mains. Pinned down with the bulbs, absolutely fine, just to use those as test tubes. So we can remove those now and put the proper 6L6s in. The reason I put the test tubes in is because this amp has a couple of RCA 6L6s and I weren't risking those on a first fire up. Now we're turning his attention to this board. And if we look here, you can see we've got 1.1 volts going on there. Nearly 1.2 volts. That's leaking onto the grid, onto the volume and the grid, and you can hear that scratchiness on the pot. And you can see this in, if I just pop this in the middle here, so plastic, so it's not a problem. If I stick this on the board, can you see there we've got 2 volts. If I stick it here, we've got 2 volts. Stick it here, we've got 1.5 volts. If I stick it here on this corner where I've actually cleaned it, there's nothing. If I go over here where I've not cleaned it, 2.2 volts, 1.9, whatever. So this board is riddled, and the filth and wax and stuff that's on this board, it's not in a great state, that board, and you can see it, where it's warped. You can see this amp has been somewhere where it's damp. We've also had some frying as well, which seems to have gone away now. It's been running for a while. So we may be changing some plate resistors, and it's the age-old story with these amps. You know, it goes back to the customer, he's using it regular, 3 months later it's frying away and it's the plate resistors. So I'm kind of mulling whether to change those, but the first thing I want to do is get rid of this wax and get this board so it's not conductive. Then check the coupling capacitors again to see if any of them are leaking. Personally, I don't think they are, but we need to test and make sure. I've got 5 capacitors coming for the bypass caps. They're on order, and they should be here about Wednesday, and we'll have those removed and put some there Vichets that are coming, so we'll have those in there. I've changed the diode on the bias and the feed resistor that goes to the bias, the drop-in resistor that goes to the bias diode. I've changed that. The smoothing cap for the bias has been changed, and there's another one there that's been changed. The caps were done in the doghouse as well in the first time. So we're going through everything really with this now. We're just trying to get through everything and make this amp good. Right, so starting at this end, we begin. So we've got to loosen all the wax up, and I have to say, when you get in close, it smells like a candle shop in here. Now, I don't need to lift these capacitors, excuse me, because I can get in underneath. A big lump of wax there, look. I can get in, let me get that out, I can get in underneath those capacitors. The leads are also lying on the board, so I've pulled the leads up as well. And so all the wax is loose now on this side, and you can just get to tell by the sound of it and the friction on this side, it's not melted yet. So we're just going to have to keep going. It's a very milky colour. And then, so what I'm doing is I'm getting in with this as far as I can, and then we're going to finish off with the cotton buds. Just get a heat gun on it and just warm it up slightly, just to soften it a bit more. You better go and get your crisps and popcorn if you're watching this. Right, we'll lift this cap because we can't fully get underneath that. We've got under that one, but we can't get under the underneath this one. So, excuse me if I keep banging the camera, and that's switched it off of manual focus. Let's move that way. We don't want to burn it, do we? There we go. You can see all the alcohol under there. I filled that up to the brim, and you could see right through it. It's already going milky. I've only just started. I think we're going to end up lifting just about every component on this amp. There's no point doing half a job. Now we're under there, that's fine. So use a dry brush on here. It's silky smooth now, and you can tell that there's no wax. And there's a bit on the edge there, because that's, and you can see it, that's a bit frictious there. So we'll have another go at that, melt that off. you know, and I don't want to start trying to scrape this wax off, because then that's just going to scratch all the board, and well, that's just going to look horrendous. So we need to do it right, make it look nice, or as nice as we can. I think this board for me, because of this warp in it and everything, this is probably why I would opt to change this if it was mine, but it's not mine, so we waxed out, maxed out and waxed out with this. Blimey. By the time I finish this, we'll have a new Monarch. I don't know the things I do, but it's all fun. You can all sit there and laugh at me and or whatever, and think, oh, I'm glad I've not got that job, and I know what a plank. Move that wire again, we don't want to burn it. I hate to see burnt wires. Clean this iron. No point cleaning the board and then ending up with gunk off the iron in here. There we go. Now we just need to better. That looks nice. I think I've moved the camera around a bit. Right, we'll clean that off. And we'll call this section done, I think, because I've got managed to get under there okay, and I've got under there okay, so that's good, under that resistor. Right, it's taken 18.5 minutes to clean that part of the board. It took 18.5 minutes to get all that mess off there. So if we look at the wax under the, I've lifted these plate resistors, and you can see, you can see the wax underneath them there, and this one's just sat in a whole channel of it, so zoomed quite in there how well you can see. But yeah, so we do need to lift these components, definitely. There's just wax underneath them. So we'll I think I might change those plate resistors as well while we're at. Let me just zoom back out again. Yeah, I think we might just change those plate resistors as well. While we've lifted them, we might as well test them as well. We'll test these capacitors as well that we've got lifted. These are being changed anyway. They're not. We're not leaving those in. As I said, we've got some Vichets coming, but just for curiosity, let's get that so the light's not shining on it and you can see it. For curiosity, we'll give them a test. .33 at one point. Yeah, he's not well. Should be 25. I mean, they're working, but they're not great. Yeah, that one's about the same. I've got the others are in circuit, but we'll try them. There's 5 of them. That's because it's in circuit. Doesn't always work, this capacitor tester, testing in circuit. Let's try this one. Yeah. So yeah, well, I think we can safely say they're shot. Let's have a look at these, see what state these plate resistors are in out of curiosity. 200k. And there, let's just see. We go in there. Accurate enough. That one's, yeah. But as I say, we have got some frying somewhere, and I kind of want to eliminate that frying, so I'm tempted to change those. That one's okay. What about this one? That one's okay. So they all test okay, but it's just whether they're noisy or not. That's there's certainly something somewhere that's noisy. So I think while I've got these out, I'm just going to change them and I've done with. And then at least if I run it back up and it's still frying, at least I know it's not those. Otherwise, I'm going to, after I've cleaned this board, I'm just going to be going in here again, pulling out components. So, which I still may have to do, but at least I won't have to pull those out because they'll have carbon films in them. Right, I'll show you where we've got to now. So we've changed these resistors here. These plate resistors, that's the slope resistor for the tone stack. There's another slope resistor there for the tone stack for the other channel, and 2 more plate resistors there. We changed those because we've got some frying. I don't want this amp coming back in 3 months' time again with even more frying, so I've changed those, and they're metal films, so they'll be quiet. Waiting for these capacitors. So I've cleaned this board now up to here, just shy of half of it, or just about half of it, not quite half, but near enough. And that, so far, we've spent just over 2 hours. So Lyle from Sonic Audio's right, it's 4 to 5 hours to clean one of these boards. It's yeah, it's a lot of work. Now, if you look at, we've got a bit of a white residue on some of this and less so here. So I finished off with this, and this doesn't leave a residue. You spray it on, it does dry pretty quick. So we'll have to lift these. I think we'll have to lift these resistors here. And I'm checking the value of the resistors as I go along. We'll lift this. We can get under this cap here. And then we're lifting this cathode bypass cap anyway, so we'll check these. And we've got this here. I think this is the vibrato, these 2 ceramics. Just keep working across, and these 2 here are the bypass caps, sorry, the coupling caps for the output tubes. But yes, a not pleasant job at all, but it's got to be done because it's got to be right. Well, this amp's bounced back once, it's not bouncing back again, so I'm just going to keep at it until it's 100%. So we're 3/4 of the way through this now, and I'm sure you can see the difference there. So we just focused on this area now. We've lifted these resistors. You can see all the wax under there. But we're nearly there with it now. And yeah, it's not a pleasant job this. It's a tedious one more than anything. But we'll press on and do a little more. Right, we've got this board done, cleaned it all now, and that took about 5 hours all told. Not that I did it all in one go, because there's only so much cleaning one can do in a certain amount of time. Well, this sort of cleaning anyway, especially. So the board is now clean, and we're going to test it and see what the results are. We've got plate resistors changed, plate resistors for the phase inverter changed. We've been through all the resistors, checked that they're not out of spec. We've replaced the bypass capacitors here as well. Replaced the bias cap and diode. We did that before we started on the board. Now we're going to turn his attention to this rectifier tube as well. And we did the video on the Vox AC30, the 1990s one that we looked at a few days ago. Did the assessment video. The rectifier flashing over is the next topic that we're going to be looking at. and this amp had the same problem as well, so we're going to be sorting that out. Now, I didn't mention the standby switch in the last video because mentioning standby switches usually results in a massive debate online. I express my opinion on the standby switch, and before I know where we are, we've got a world of pain, people disagreeing, people unsubscribing, blah blah, whatever. So I generally don't bother mentioning that. But obviously, on any amp with a rectifier tube, it really shouldn't have a standby switch. A rectifier tube is slow start. You know, so when you switch it on, as the tube's warming up, you see the plate voltage rising. So they're not designed to have the plate volts smack straight onto them, and they tend to flash over inside. So we're going to fit some diodes on the tube rectifier socket to help prevent that, and I've told the customer that it's not to use the standby switch. I've ordered a new Softec GZ34 for this amp, and that's now been delivered, so we should be putting that in shortly. But what we're going to do now, because of course we've had this amp, you know, we've been lifting components and everything else, so what we're going to do now is we are going to fire this amp up on the solid state recce and on the bulbs, and we're going to just check that everything works on it, because obviously we've been lifting things. Now, we had quite a bit of frying as well on this amp, which is why I changed the plate resistors. So we're going to see if that's gone, but most of all we're going to see if the board is no longer conductive and we don't have the scratching on the pots. We've got the solid state rectifier back in. I've run this amp up and checked it's running okay. So we're going to have a look now to see if we have got any leakage anywhere on the volume pots, any leak in DC, or any leakage along the board after we've cleaned it. Will it be successful? Let's find out. We'll plug in. We're on the bulbs because of course we're still using the solid state rectifier, so we have to stay on the bulbs or we'll have too much voltage. Right, just pull the camera back a bit. No scratchiness on there now. So let's get the meter. I've got the meter above here, which is monitoring the plate volts, which is there. Right, let's see then. So we need ground, go onto the board. We've got nothing. Remember we had volts on there before. We've got nothing. Let's go onto the wiper of the pot. On this one, got nothing. Go around the board in various places, nothing. Yep. Let's try this pot on the wiper. Can't see the meter now, can you? Do nothing there. Nothing there. So it's looking like it's been very successful. Little bit there still. Nothing there. But still a little bit of leakage there around these. This is where the centre tap. But yes, there's a little bit there. But all where these preamp tubes are, there's none whatsoever. And you can see now where we had those scratchy pots before. Now when I tried this earlier, we did have a little bit of frying. That's the reverb that I'm turning up now. You can so got a little bit of frying, and that's like the typical carbon comp frying there. Barely hear it though. As it warms up as well, it gets less and less. Barely hear that. Of course, what you worry about is it getting worse as time goes on, you know. But there is a very, very tiny bit of frying there when you turn that up. And it's actually still there with the reverb down. Let's turn this channel down. And it's still there with both channels turned down. And all the tube sockets have been cleaned. And I mean, it could be a tube. You probably barely hear it, but it's certainly not massive. It's slight. Something to keep an eye on, definitely. And it does go away when the amp gets fully warmed up, so don't know on that one. We'll just keep an eye on that for the time being. But there we go. We've put from, there's just a little bit on that end of the board, and I don't quite know why, but there is, as I say, there is some, you know, tremendous voltage there, because if we go to here, you can see we've got the plate volts there. So when we go on to there, it's a little bit there, but yeah, but I guess most of these amps out there will have a lot more than that. But the main thing is we've got nothing leaking down here on these grids, or these tubes, because these tubes are not going to last long with DC on them. They just don't. So I'd call that pretty successful, really. Now, that took 5 hours to clean that board. And I chose to undertake that. I've not charged the customer for it either. I decided to clean this board because I wanted to do it for the channel, for, you know, for entertainment value, and also for people who've got these amps, you know, when they thinking, is it worth cleaning the board, is it, you know, or having it cleaned. I mean, obviously if you're going to pay somebody to clean it, it's a lot of money. But this is why I do these things on the channel. It's you know, there's only Lyle Caldwell who I know has cleaned one of these boards, and he did say it took him quite a few hours, and he's, you know, there's no question about it, it did. If you've done it right, and he's done it right, there's no question, because he does everything right. And so if you're going to do this, you've got to lift the components. It's no good, you know, if you're going to do it, then do it, clean it all off. It takes a long time, but has it been worth it? Yes, it has, because in the long run, these tubes are just, as I say, if you're using this amp a lot, you know, if it's being used a lot, they've got DC leaking onto the grids. The tubes are just not going to last a long time. Just over biases them. And so yeah, we've got rid of all the scratchy pots, and it's been successful. So, you know, is it a job you can do yourself? Yes, if you can solder and you've got the patience, yeah, you can do it yourself. You watch me do some of this, so you know how to approach it and everything. You just have to be careful when you're doing this, is to do it a bit at a time. If you're lifting the plate resistors, it's a good idea to change them. You don't have to, but it's just, you know, we don't want frying plate resistors in 3 months' time. It just carbon comps, so changed all of those, put the metal films in, they're quieter. So yeah, it's and what, you know, while you're doing that, you can go across all your resistors and check them, make sure you've got no out of spec resistors, change the ones you have. At the end of that, it's 5 hours of graft, but at the end of it, you've got a very well running amplifier. So let me know what you think in the comments. Right, so now we've done that, and the mainstay of this video was cleaning the board. That, you know, that I've had to fit a transformer to this amp, and while I'd got it, I thought we'll clean this board, make a thing of it. So all that's left to do now is sort out the socket, the rectifier socket. So we've put a new tube socket on there, and what we're going to do now, before we put this new Softec rectifier that I've ordered, this rectifier tube, this GZ34, we are going to fit some diodes in series with the anodes on that rectifier tube, and that is to protect flashover. Although I've advised the customer not to use the standby switch, I'm going to cover this topic more when we do this part 2 of the Vox AC30, and we're going to cover that a little bit more in that video, because that amp's got numerous problems and we shall be looking at some of those problems. Right, you can see we've got the diodes on there. Those diodes are 1N4007, and you can see how we've wired those up there to make them really secure. So let's find a pointer. And remember, if you're doing anything like this, make sure the caps are discharged before you start dappling. So these are the AC feeds, and they go on pin 4 and pin 6. So obviously you're putting these diodes in series. So obviously you don't want to just connect the wire to one end of the diode and then put the diode in there. The cable end needs some support. Now pins 3 and pins 5 are no connection. So they have no connection to that's actually the solid state rectifier. I've not put the tube in yet. Otherwise I wouldn't be soldering on it. So we connect the anode side of the diode to pin 3, and then we connect the cable to it, and then we bring the diode over to pin 4 where the wire was connected originally, so the cathode side of that is wired there. And what we do on this side, pin 5, is no connection, so we do exactly the same with pin 5. We connect the anode side of the diode and the cable together on pin 5. We take the diode over to pin 6 where the cable was originally connected. There you've got your diodes on there, and that's how that's done. And that will prevent the tube from flashing over. And of course, don't use the standby switch. Right, here we are, brand new Softec 5AR4 GZ34, so we're going to pop this in. Right, we've got the rectifier tube in. Got 367 volts, but I'm on 200 watts of current limit in there. So I'm just going to drop another bulb in there. Now we've got 415 with 250 watts of current limiting. So that's going to give us quite a high voltage. Let's just pop the other, that's 300 watts of current limiting. So that's quite surprising. I thought we'd have a bit less plate volts than that. We're still on the bulbs, remember. So we've got 230 volts going into this amp. If we just have a look here, on here, 230 volts, and we're drawing 430 milliamps. And I think that could be a little high on the bias there. Now these are the original tubes that was in this amp when it came, and they've been in there years, so they look like the original tubes, to be honest. So yeah, 434 with that rectifier. So if we come off the bulbs, wow, well that is the same voltage as the rectifier. So is that because we've added those diodes on there, has increased the plate volts, I think, because that's like 460 volts, and we only had 462 on the solid state rectifier, and we're drawing 480 milliamps. I'd expect that to be around 380 milliamps being drawn off the wall. Man, that's another thing. Look at the voltage on the wall. If you look there, 241.8, so nearly 242. That would be at 233 this morning, so 232, something like that. So yeah, you can see the difference it makes. You can, if we look at that now, you can see 457, 458. So put the bulbs back on, it'll take us down to 230 volts. 233, 32 there. 231. You can see that's now at 436. So yes, I think putting those diodes on there has whooped up the plate volts. Now I've got the bulbs on at the minute. As I said, I've got 300 watts of current limiting, so I'm going to check the bias while it's on the bulbs. .3. So let's just check that on one of the tubes, 3.3. Now I've stuck this sticker on here from last time, so 79 ohms. 3.3 divided by 79, that's 41 milliamps, and 18.2. So let's switch off now. Right, I've just checked the tubes. They are 6L6 GCs, so that means they have a dissipation of 30 watts, and if we times that by 0.7, 21 watts is 70%. So that's where we want to we want to be. So we'll flick it off the bulbs now and check the bias off the bulbs. Now it should give us 200. We'll be at 239 volts. There we go. So yes, I don't know why I thought those were 588 ones. That's why I was I weren't sure, and that's why I was looking at the current thinking that looks a bit high when it's idling on the wall. But if the that explains if the 6L6 GCs, we'll see a bit more current because we can dissipate them higher, and they're already over. A 5881, you'd be setting it at 16.1 watts, 16 watts at 70%, but a 6L6 GC is 21, so we're already at 18, aren't we there? So hence why we've got that little bit extra current. And if we come off the bulbs, it's about 470 milliamps at 450 volts, and you can see now that if we look, we're now down to 451, and we're down to 237 on the wall. So as that wall voltage is coming down, our plate voltage has already dropped considerably there. 3.57. So we'll start with that. We'll divide that by our 79. Now I've got 45 milliamps, and you can see we're back up to 240 on the wall, and if we go up, we're already up to 4, 5. That 3 volts has given us 6 volts on there. So yeah, you can see where that's going. So times 4, 5, 6 is 20.6 watts, and that's perfect. It is. That's bang on. Now I've only done one side because we're going to try and use this balance pot to. I've got one side done. We'll test the other side, and then what we do is we use the pot to balance them up. So now if we come over to this side here, 3.6 there. Now this time we've only got 71 divided by 71. So we've got 50 milliamps on that side because we've got less resistance there. You see, we've got 8 ohms less. So we've got 50 milliamps, and the tube's probably just drawing a shade more current. So if we divide that by our 459 we've got up there, we've got 23 on that side. So that tube's drawing considerably more current than the other tube. So what we might need to do there is try and swap them round, I think. So I think that's what we'll do. We'll swap the tubes round and see if we can get a closer balance. Right, so I'm monitoring the plate volts now across that tube that's slightly over biased. We've got the bulbs on, so I'm going to take the bulbs off now. And you can see it'll get up to about 3.6 before it's fully warmed up. But what we're going to do is now we're going to turn this trim pot, and that's going up, so we need to come down. So we've come down a bit there, so we know we're going to be around 459 with our voltage, plate volts. So we've got 3.47 divided by 71, that's down to 48 milliamps times 459-ish, so 22.4. that's still over. So we're not, yeah, we may end up having to just change the bias resistor. Let's bring that down. It's going up. That's down to 44 milliamps now. I think we're looking for about 45 milliamps. So that may now have just gone a little too far. And of course, we've got to consider the other side as well. You have to be very careful when you're testing on this amp. If you're measuring the plate volts, look where the fuse is for the and it is off now, so I am pointing at it, but I've pulled the plug out. Look, if we just show, look where the fuse is there. So be careful if you're going in here, because you could quite easily cause a short in there. It's really iffy. We'll be very careful. Right, so let's try the other side now. So we'll put this back in, we'll let it warm up for a minute. There we go, that's going up. We'll see what we've got on that side. And that looks to me like we're going to have too much on that side now, because that's going up quite high. I know we've got more resistance, but that's looking a bit too high to me. Might be wrong, but 47.8 milliamps, yeah. So we've got it's too high. Right, so what I'm doing here now is got the amp turned off and unplugged now while we're doing this. So we've got some jumpers here and here. We had a resistor going across there from this cap to this cap here, and that was dropping the bias voltage, and it was a 3.3k which measured 3.4, and that was dropping the bias by 10 volts. So I jumped in a 2.2, cut that resistor out, jumped in a 2.2, and that was a bit low, left us about 17 watts. So I've now got a 2.7k here jumped in. You can see it just coming shot there, it's a bit out of focus, but so I've got that jumped in now. So we're going to have another go, and I'm hoping that gives me about 19-20 watts, and that'll do us nicely. So looking up at the meter on the wall there, on the shelf there. So you see that coming up there on the meter. Coming up. And got 3 volts. Just got to let that warm up. You can hear the frying again now. So you've got 3.2 there now. $40 milliamps, 40.5 milliamps. That's given us 18.3. That's given us. So we now need to look at the other side. So that's given us a little bit more, but I may leave it around there. So let's look at the other side. Let's just go around this side of the camera. So you can just about see that meter there. So what we're going to do is go in and 3.2 on there, but remember we've got less resistance on there. $45 milliamps on there times 453, so we've got 20 watts on there and 18 on the other. So all I need to do now is twizzle this balance pot, and we should be good to go. Hopefully we can just balance it up round about 19 watts. So that's 19.5 I've got on there now. What we got? So let's just see what we've got on the other. 3 volts. 19.1. Thank you very much. That'll do me. That's perfectly balanced, 19 watts, and that's absolutely fine. We biased them 2 watts under just to get a bit more life out of them. And we're drawing less current idle now. We're drawing 450 milliamps on there. We were up to nearly half an amp before, so that's it. That's biased and it's all done. Right, we've got the old Vibrolux ready for a demo, and it's as quiet as a mouse now. I just went through and cleaned all the tube sockets again, preamp tube sockets, and yeah, we're pretty quiet. So we'll see how it goes on. So let's give it a blast. I've tested the tremolo, that works, although I've not got the socket bridged. Obviously we've not got the reverb tank, that the customer's got, that's in the cabinet. So yeah, that's the vibrato channel. I'll pull that out with that hand. The old thumb's giving me some jip today. It is. Oh dear, it was in tune when I bought it. So there we go, that's the Fender Vibrolux there. Very quiet at the moment, but wouldn't surprise me if the old carbon comp syndrome popped up at some point in the future. These amps now, they're really old, and they're just, the carbon comp resistors aren't great in them. But yeah, at the moment it's really quiet. So yeah, that'll do it for this one. So let me know in the comments what you think about the board cleaning, and I'll see you all in the next video. Bye bye for now. Right, so thought we'd have a look at this before we go. This was sent into the channel by Mark, so thank you very much for this, Mark. And this is some very old soldering paste, and it's in a very gumption like tin. So the problem at the moment is that my thumbs are caning me that much I can't actually open it, and I don't want to force the tin and damage it with something else. So we'll probably have a look inside this in the next video. But yes, it's so we could actually here have another tin of a different type of gumption,